Hi, everyone. My name is Jack Coor, and I'm the research director at Payload. Welcome to our webinar on edge computing in Leo. Today, we're going to go through the landscape of onboard processing, what's available today, and where we're going. This is a webinar topic we get requested a lot, and I think it's just top of mind for a lot of folks. So super excited to have this conversation. Also, just there's a Q&A chat box below if you have any questions, and I'm sure you will. Just feel free to pepper them in that box. We're going to try to have just a very open conversation about the landscape, and we'll try to get to most of them. But with that, I want to introduce. We have a great set of panelists, and I want to introduce the folks first. I think Gonzalo, maybe we'll start with you. Can you give a little, maybe 1 minute introduction on yourself and Astroscale?
Hi, hello there. My name is Gonzalo Aguirre. Can you hear me, by the way?
Yep.
Yes.
Good.
Okay. I'm Gonzalo Aguirre. I am originally from Mexico, where I studied mechatronics, and throughout my career, I had the opportunity of working for the aerospace and automotive industry originally. And when I moved to Japan, I started working for a deep tech startup where I was privileged enough to work with a lot of brilliant minds working on autonomous driving applications, robot picking applications for fulfillment centers, logistics centers, also using machine vision techniques, and also personal robots, development of personal robots from the ground up. And after that, since last year, I joined Astroscale in September as the director for robotics and machine learning. And since then, for the past year and a few months, I have been working in the global coordination of the efforts to deploy machine learning and robotics for on-orbit servicing. And for those who don't know Astroscale, basically our company is focused on delivering space sustainability. Basically, we clean trash on the space. Well, that's one of the service lines. But basically, we try to promote the sustainable development of space through missions such as refueling, debris removal, which is trash removal, or life extension of satellites and so on. So that's basically what I'm working on. Thank you very much.
Awesome. Yeah, thank you. And Raul, we can go to you now.
Sure. I'm Rahul Rugani. I'm the Chief Systems Engineer at Arcasys. I've been with Arcasys for about 4 years now, and I've been working to build up our platform. We develop a long-duration platform for hosted payloads in low Earth orbit, essentially a robotic space station that we can host up to 60 payloads at a time on. These payloads plug in with an interface. They can perform their mission. We provide power, data. We handle all of the bus operations, data collection, and then when our customers finish their missions, we can swap them robotically for new payloads. So we offer a low-cost option to test in low Earth orbit.
Awesome.
Thanks.
Jennifer?
Yeah, hi, I'm Jennifer Little, Chief Revenue Officer at Ramon.Space. I've been with Ramon since September of last year. And I came from the industry. I've spent my entire career in telecommunications. Prior to Ramon, I worked for a company that was really focused on the ground. Ramon.Space was very interesting to me because I think they represent really what is looking at the future of our industry, and in particular for this topic, edge computing. Ramon has developed a product line called NewPod, basically a space resilient computing, edge computing platform that's quite state of the art. And so really happy to be here today with both of my colleagues here on the call, both of whom I find have amazing missions and represent also the future of what's happening in space. So thank you so much.
Yeah, thank you. And maybe for the first question, let's dive deeper into the product that you guys are offering. So you're offering a edge computing platform. that can be integrated with customer satellites and help with their onboard processing needs?
Yeah, customer satellites or space type of vehicles, including ones like Arcusys and or Astroscale are developing. Yeah, so Ramon started as a chip developer, developing radiation-hardened chips over 20 years ago. So it's been around for a while. It used to be known as Ramon Chips. It's now called Ramon.Space. The company pivoted in the 2019 timeframe beyond chips into systems for space. NewPod is our product line for edge computing, and it's really taking advantage of the deep level of expertise we have in Ramon.Space in terms of radiation hardening and radiation tolerant systems, along with the expertise from our employees, deep expertise for our employees in edge computing platforms. So NewPod is and all of our products are intentionally modular in terms of approach because each mission is specific, right? So for edge computing, our current base platform can support any combination of storage and computing, AI application computing. And a current base product for edge computing is roughly about 4 terabytes of storage sitting in our form factor there. And it's customizable based on the mission definitions.
Great. And Gonzalo, as a user, as someone who has space activity, how do you think of edge computing? Is Astroscale using edge computing, onboard computing, on their vehicles today?
So yes, basically we are now running missions in space. As I mentioned, Astroscale has different offices across the globe. And now, for example, our Japanese office is flying a mission to observe upper stage rocket body in space. And so we have some payload there to observe the object. And for the future, we are going to go and collect that upper stage rocket. And in that case, we're going to be using a robotic arm to capture that piece of debris and deorbit it. So in that case, we are looking into how edge computing can help a lot of the future missions. It's not only that, but we have other service lines as well as the robotic arm payload. We also have refueling missions that will do complicated docking operations in space. So a lot of what I will describe the main drivers of using edge computing in Astroscale probably can fall around 3 different categories, which is to increase the safety on missions, also improve the efficiency first, and then eventually the scalability as we move into a more sustainable development of a space where we will have multiple missions doing all sorts of things from removal to refueling to assembly and manufacture and things like that in the future. And also finally the third driver, I will consider that is like the overcome the downlink limitations. So these are kind of, I think your question was more focused on what we are doing right now, but we are also looking more into what can be the future, but definitely.
Right. And Raul, similar question, but I know, how is Arcusys looking? You guys will be operating a long-term platform that operates for 10, 15 years in space. How are you thinking about integrating edge computing, right? That platform hasn't been deployed yet, but how are you right now in the design development phase thinking about integrating edge computing?
Yeah, of course. So that's actually twofold. We do plan to use edge computing for some of our RPO operations when OTVs come to dock and bring new payloads to our platform. But what's more interesting is that we plan to offer edge computing services to all of our existing payloads on the platform. So all of our 60 plus payloads that are attached to our platform, we can resell services from a edge compute platform such as the Ramon.Space new pod to all of these other payloads as there's downtime on the system.
Okay, that's interesting. So it would be, so perhaps instead of the company's individual payloads, those 60 payloads having their own edge computing capability, they can tap into the broader Arcasys systems network.
Yes, exactly. And so we want to foster an in-space economy, essentially, to be able to resell these services to other customers.
Yeah, interesting. And you have a very unique perspective because theoretically you'll have 60 different customers and 60 different payloads. So maybe you can provide insight on how folks are generally talking about the need for onboard processing. Is it something that your customers have discussed with you? Or maybe
Yeah, a
it's
lot
something
of our customers
that-
have inquired about how they can minimize the amount of data they want to bring down. We have a lot of customers who want to do biological experiments or TRL raising missions. And for most of those, they can do the compute in space. They don't need to bring a huge data set down and do the compute on the ground. We can save them money by reducing the amount of bandwidth that we need to bring their data down and instead offer them in-space compute services.
Awesome. And maybe Jennifer, I can ask you if you can jump on that. How does onboard computing allow the cost of downlinking, for example, to decline, just like practically? And
Yeah, great. Perfect example. So we did a demo not too long ago with a company that has an AI application that does cloud detection on images that are captured. So we can process those images. We capture the images. They're stored and processed on NewPod using a containerized Linux environment, from this third-party company, and filter out based on their application, filter out those images that have clouds providing blocking of the images, right? And filter those out. So downlink only really the good applicable images. There's a lot of data that's captured in space today. A lot of data. If you look at, SAR missions, SIG and Earth observation, remote sensing, just a very data intensive type of an environment. So being able to do some processing of that data on board really does reduce the pressure on the downlink that are available. And if you look at a platform like either of these two colleagues of mine have, you really need to be mindful of that. Within an edge computing platform like ours, you can dedicate information to be sent to, say, for example, over an OISL to another satellite or space vehicle. You can downlink the data and continue to process it and downlink when it's available, when the downlinks are available, schedule it. So it's really just taking what we know today of an environment like AWS. And we do support cloud computing on NewPod as well. But taking an environment like AWS and an application like Airbnb, everybody knows the Airbnb AWS example, right? And really you taking advantage of that environment just up in space to do that level of computing. BMC3 type of application, so both commercial and military applications could be very critical to conduct up in space.
great. And then what is our current capability? The computing platform that Ramon.Space has is in orbit and has been tested.
It's not TRL-9 yet. It is being prepared. We passed CDR. We're preparing to hand off FM modules before the end of this year. And we'll fly next year in space.
Okay. Is it you're the chief revenue officer? Is it a little bit like all your, like Rule was, Rahul was alluding to this, but for the customers you speak with, is it pretty unanimous that folks would want this technology? It's just a matter of getting the proof of concept, and when is the technology going to be ready and certified to fly?
Yeah, and the technology that we have in NewPod is not a technology that's going to be used on a very short duration, 18-month mission, right? This is very high end, very resilient computing capability for space, right? And it's meant for unmanned systems in space today. If somebody's sending an experiment to the ISS for 3 months, NewPod might be a little bit overkill for that, right? First of all, the environment within the space station is not the same as the environment in a LEO constellation, MEO, or geosatellite. So we have to look at the circumstances there to really dictate what level you need. If the storage is just for example, the storage in an edge computing platform, if the storage is just needed for, a short duration period of time, maybe what we provide in NewPod is not appropriate. But for the case like Arcasys, where they plan on deploying these capabilities for long periods of time in space, you really do need a resilient system. And one that is also upgradable and software definable in space as well, right?
Yeah, that's a good point. We should have that be another question maybe in 8 minutes, because I do want to get into that. And maybe, so Gonzalo, Raul and Jennifer spoke a little bit about downlinking, and that's a little bit less relevant to Astroscale. But I really want to double click into how, like, rendezvous proximity maneuvers and life extension and in orbit maneuvering, how edge computing will enable that and unlock a lot more accuracy with what you guys are doing at Astroscale.
Yes, I think I will disagree that that downlinking is not of interest to us. As I mentioned, we are running currently a SSA mission, situational space awareness mission, where we are taking a lot of data from observing a client, and when as the complexity of missions in space grows, more data will be created by our missions, and it's not only from image sensors. We are talking about, as you were mentioning, docking operations, which will be using robotic arms. Those generate also a ton of data, and also maybe depending on the number of sensors that you have, if you include, for example, additional cameras at the end in the end effector of the robot for performing like precise operations during manipulation, or let's say skin sensors that can in the robot that can sense the type of grasp that is happening. So a lot of data gets generated from those kind of new sensors. So or even when you are doing hyperspectral imaging in debris on space to characterize them, for example, that is an explosion of almost like 200-fold on a traditional camera, depending on the number of bands that you're looking at. So being able to get insights of the data rather than the raw data itself by analyzing it on the space and just downloading those key insights to perform better operations, it's a huge win for us. Yeah. On top of that, when you're talking about safety, so like if we can process that data and react based on the data that we are getting in an automatic way, that will be a huge win also for not having to rely on teleoperation, because we know that for manipulation in space is very difficult. It has been tried before, like for example in the Japanese mission ETS-7, they had a bunch of problems trying to do teleoperation, and it's now clear that autonomy is a big part of on-orbit servicing in the future.
Yeah. Interesting. Gonzalo, I love your the artwork in the back. the astronaut cleaning up cleaning up Leo. That's really good.
Yes.
Yeah, the vacuum. Except vacuums in space are not going to work, so it might be an issue. Um,
Definitely not.
uh, we have a question in the chat for Arcasys on would edge computing look a bit like a local cloud computing system available on demand to all those payloads that Arcasys would host on their larger platform to share those resources?
Yeah, definitely. It'll be kind of like an AWS-like system. You can queue up tasks, and they'll be run based on priority in the queue and sent over to the edge compute platform.
Awesome. And for those who weren't on at the very beginning, Arcasys has a long, basically what they do is they're hosting up to 60 payloads on a long duration platform similar to a robotic space station that can be in orbit for 10, 15 years. And maybe sticking with Arcasys, uh, given that the platform it will be up there for long duration, 10, 15 years, how do you think about uh, updating technology, right? One of the advantages to Leo is that advantage or disadvantage, but Leo satellites re-enter and have maybe a 5, 6, 7 year lifespan, and then you can upgrade technology for a new launch, upgrade satellites for new launch, and you continuously be on the cutting edge. How do you guys think about upgrading the Arcasys platform, and also how do you think about that in terms of computing technology?
Yeah, so everything at Arcsys that we built is modular. So we design everything to be upgraded in orbit. So even things like solar arrays, batteries, they can be replaced robotically in orbit because we can add on a new battery module using the interface. We can swap a solar array, add a new antenna. But also, since we swap our payloads regularly as our customers finish their mission, let's say our customers do a 6-month mission and then we send up a resupply, we can swap these payloads robotically. The edge compute module would be essentially another payload. It would connect with an interface that transfers power and data and does a mechanical lock. And then when we want to send up a new edge compute platform, we'll be doing regular resupplies to their station every 6 months with OTVs. We'll just send up the new Ramon.Space module or whatever is available and plug it into our system, commission it, and then open up its capacity to our customers.
Cool. And Jennifer, how do you think about upgrading software on orbit? You know, when it's deployed, when the computing, when Ramon.Space's computing platform is deployed, how does that work?
Yeah. The customer will have that capability to do those upgrades. We'll provide either the firmware or the software upgrade packages to them, and then they can schedule that during their scheduled mission maintenance time period. So we think it's really critical to be able to do that as maybe missions grow or change over time. The ability to schedule resources that are used in edge computing and to change that schedule as needs evolve. We view that as very critical as well.
And we have a couple more questions in the chat. For a reminder for everyone, if you have a question, just put it in the chat. There's a question for you, Gonzalo. Do you see the question on Astroscale? Do you foresee debris removal by swarms of smaller autonomous vehicles? If no, why not? If yes, what do we need to work on to make it a reality?
Yes, that's a pretty good question. I don't think that we have that currently in the roadmap, but it's definitely not out of the question. It will depend on how the market of on-orbit services evolves. But as far as I can tell right now, I do see the need in the future to have like collaborative missions, maybe not a swarm of multiple spacecrafts, but definitely collaborative missions when we start getting into things such as assembly in space or recycling, upcycling of materials. So one of the advantages is that that we have generated so much trash in space is that we can reuse it. So if we can have sort of like foundries in space that could help manufacture pieces out of the materials that we collect, we could send missions up there to take apart satellites and bring those materials to those factories to be reused in space, rather than to have to manufacture things in ground and then shoot them up, send them up. So definitely for this kind of operations, I think that collaborative robotics will be necessary, and that's definitely will only be possible if we have edge computing, powerful edge computing in space.
Right. We just got a really, really great question for you, Jennifer.
Okay.
This will be an interesting one. What do you predict the top 3 to 5 use cases for edge computing will be?
I would say I think the big three are going to be in Earth observation and remote sensing. I think the other one to drive edge computing is going to be in the area of space situational awareness and BMC3. And I would say from the third, I would look mostly at infrastructure servicing, like Astroscale is doing. And I think that's going to be critical going forward, particularly now as we know there's lots of debris out there.
Yeah. Is edge computing relevant for SATCOM?
Yeah, absolutely. We can use edge computing and applications, AI-based applications, in the area of beamforming. Take 5G beamforming, using a third-party application that can provide optimal beamforming based on live data and traffic patterns. I think is exactly. I think answers that.
Yeah. Interesting.
Mm-hmm. Mm-hmm. And we have an onboard processor today that's past CDR as well. And we are in the course of developing our 5G reprogrammable and regenerative processor. And we will use AI in that case and on that product line, some of our own and also from third parties too.
Gonzalo, you have your hand raised.
Yeah, I would just like to build add one additional use case that I think it will apply to almost every other operator in space is autonomy. So autonomy, it's an important driver of the future space economy, and satellites will need to have a huge degree of autonomy to perform any kind of operations, call it remote sensing, docking, on-orbit servicing. So just simply having the capability of having really strong FDIR capabilities to recover, to react autonomously, and without the need of human intervention, it will be a key point for scalability of that space economy as constellations continue to grow and operators continue to launch and the cost of launching vehicles goes down. So more and more, like you cannot have ground segment running like 1,000 satellites that don't know what they are doing themselves, basically.
Yeah.
So I think that will be another huge use case driver for this.
Yeah. And how does edge computing enable AI? And in some ways, maybe Rahul, this can be a question for you, but are the two going to become synonymous? How do you think of AI in general?
So, I mean, AI is obviously a big buzzword. It can mean a lot of things. In terms of what we do at Arcasys, AI means to us autonomy and being able to have the spacecraft, at least to a certain level, be able to think on its own and react to protect its operations. So in terms of how that works with edge computing, AI is really processor intensive. So having an edge compute module and something to offload these tasks onto is very useful from our perspective. But really AI, it is augmented by edge computing. It's not a requirement of edge computing, but they work in tandem.
Yeah, and then you mentioned the intensity of computing needs, and that gets us into the swap conversations. I think there's a good question in the chat related to this. Is power, specifically talking about power, is power an important consideration and constraint for scaling space edge computing, or does it mainly drive power generation requirements?
So I can answer that. I mean, yeah, definitely. The more compute power you want, the more power you're going to need to generate and provide, and then more thermal load you'll have to shed from the spacecraft. I expect as we progress throughout the next decade, compute modules that will get more efficient will require less power. But for now, we're as you it's going to scale linearly as you grow your if you want 5 times the compute capacity, you need 5 times the power. So at least from the ArcSys perspective, since we design things modularly, we can just add on more solar arrays, more power generation capability. But I assume for Astroscale that is limited in how much power they've already put on their platform.
Yeah, Gonzalo, do you want to answer that question too? How do you think of power when thinking about edge computing?
Yeah, I think that power is a significant driver of how we think about edge computing. But thinking also about like how to just going a little bit back onto the question of AI and if it's synonymous with edge computing as a powerful and a power hungry platform. AI is not necessarily completely it is not a causal relationship. We have the ability to deploy AI in very small platforms. We have proved that in the ground, and we have proved that also in space. So we can deploy AI in very power conservative systems and very computing restricted environments. There are methods to reduce the model size and the computational load and still deploy AI in not so power hungry systems. What edge computing really is a game changer, or what it can be a big enabler if you have more power available for the edge computing, is that you can more easily deploy applications. You don't need to customize your application in that particularly restrictive environment, and that minimizes your time to develop things. And also, not only that, but it also improves your safety, because as the complexity of your AI grows, there are inherited risks on deploying AI, and you would like to also be able to implement some safety guardrails around it. So yes, you would. Okay, going back to the conversation about power hungry systems, yeah, we need to keep a balance there between power and safety, and how edge computing will play to enable the deployment of safe and robust algorithms in space, I think.
And Jennifer, how does Ramon.Space think about limiting the power needed with your edge computing platform?
Yeah, I mean, we really our objective is always to be as power efficient as possible. So from an AI perspective, really super power efficient AI inference in space, right? Generally about 1 TOP per watt of power. Our new pod platform is currently designed to handle about 90 TOPS for about 100 watts, right? And so we do use both hardware acceleration and AI acceleration and AI engines that are very power efficient. and to improve our efficiency, by the way. Yeah, and we use FPGAs that enable us to add hardware accelerators as and as a firmware upgrade, right? So our goal here is definitely on the efficiency side here, knowing that processing takes a lot of power. So our design is based on maximizing each watt of power for our entire platform. I hope that answers the question.
Yeah, no, it does. And
Yeah.
there's a couple questions in the chat, Jennifer, I think for
Yeah.
you, that
Okay.
important we address, and maybe we've talked about it before, but
Okay.
what type of AI accelerators like GPUs or VPUs can we expect in our current or future edge computing platforms?
Yeah, we don't use GPUs for our AI accelerators. We have other kind of what I would say engines specifically designed based on terrestrial AI inference, but not we don't use GPU for that.
Great. And then there's a question on, is the edge AI device an OBC and payload processor or only a PP?
Oh, very good question. Really
Yeah.
good question. No, it's today just a payload processor, but we can connect to the OBC and command back and forth between the OBC.
Great. And then maybe one last one as we just like rapid fire Jennifer
Yeah,
right now, but I
that's
think
all right. Don't worry about it.
yeah. Have customers indicated an interest for edge computing AI for fault resolution on orbit?
Fault resolution? Not to me. No, I have not been approached by anyone on that. I mean, maybe Gonzalo has some information on that. If they've been asked to look at that on Arcus's side of thing.
Yeah, so from Arcus, none of our customers have asked for that, but at Arcus, we do, part of our ConOps is using edge compute to do our fault operations.
Okay.
Exactly what does it mean by fault resolution in this case?
Yeah. Yeah, that's a good question because we support all FDIR on board, right, on our computers, but I don't know what I'm thinking the application of fault resolution, maybe some, I don't know. I don't know of any fault resolution AI applications.
Yeah.
So in that related topic, something that pops up maybe often when you think about AI for space is the tolerance to radiation events. So how will a system, an AI solution or AI system will recover from an event, a reset in the processing unit if it occurs? And this is particularly interesting for systems, for example, that work in time domain data. So like where you're looking at trends or something like that. And if you get a reset, like probably that affects how the model performs. And this is an interesting conversation for what the future of AI for space needs. And I think that there will be the need to develop models which are different from the current models on the ground that assume that you have sort of a perfect computing system, that a fully reliable platform compared to the one in space that could have these sudden events. Maybe that answers the question. I'm not sure.
And then maybe let's talk about some of the headwinds and some of the difficulties. Rahul, maybe we'll toss this one to you. Is cost, what are some of the headwinds that you see implementing edge computing?
For implementation, really, it's getting the amount of power you need to run the system and the cost to put that in orbit. From the Arcus' perspective, it's not so much an issue for us on getting it onto our platform in orbit, but really just lining up the customers to use the platform such that we can at least recoup our investment of putting it on our an edge compute platform on our port.
So power and costs, Gonzalo, what do you see as some of the headwinds? Like I think everybody sees this as an important capability, but what could prevent mass adoption in the next few years?
Yeah, I think that's something that has helped. For example, the development of AI, it has been the development of common tools and frameworks that facilitate the deployment of AI applications in all the industries. And I think if we can create this kind of frameworks, could be a good way to incentivize or facilitate the transition to transform what is a traditional way of developing software for or spacecrafts into the modern era where you will be doing data-driven missions using a bunch of machine learning models and other kind of more advanced algorithms. And we saw sort of the same shift during the change in the automotive industry, from having like hundreds of ECUs running throughout the car, developed by different manufacturers, and only those suppliers understood how their algorithms get deployed in those very particular platforms. And so, if we can, and then that disappeared and became like one single powerful supercomputer that we have in the car, and now all the algorithms run there, and we can have something like a Linux OS supporting multiple containers inside that huge platform and running very easily very easily and safely, like in sandboxes applications. So if we can have this kind of tools also for space, that will be like maybe very useful, and maybe that's something that will be interesting for Ramon.Space. And I think probably they are already exploring those avenues, like providing the necessary tooling for development, but also for validation, like as I mentioned earlier, like the validating how models or these applications behave in space, and to be able to validate them when these errors occur. That will be like a powerful driver for adoption, I think.
Yeah. And Jennifer, there's a question, another question for you on summarizing some of the specs.
Sure.
I can read them off, but it's the TOPS, watt, inference performance, environmental testing, rad testing, TVAC, latch up. I don't know if you want to kind of run through, if you have that top of mind, and you can just run through specs a little bit.
Sure. So, power range, I mentioned roughly between, depending upon how we configure a new pod, anywhere between 40 and 90 watts. The weight is roughly anywhere between 5 and 6K. We can have up to 4 terabytes of storage on there, with 3 gigabits per second of read-write capability. Rad hard to 30K rad, and we're testing at higher levels right now. Multiple interfaces are supported in and out of the box. I think I hit kind of the big ones there. Did I?
Yeah. Thank you.
Yeah, about 90 tops, depending upon the needs, right? If we don't need 90 tops, don't need that power, so it's kind of customizable from that perspective.
Yeah. And when do you have a timeline on when you would expect the product to be commercially available?
Yeah, I mean, we are selling it right now. It's, some of the components, like the storage is already TRL9. Some of our silicon is already TRL9. But we are taking orders now. We are working with multiple customers and taking orders now.
Right. Okay. And then maybe since we are coming on our last 15 minutes, if there's any other questions from the audience, just put them in the chat. We've had some really good questions so far, but maybe let's turn our attention to the future and think about, the next 5 to 10 years and what edge computing could look like. Do you think it's maybe Rahul? Maybe I'll toss this one to you first, and I know Gonzalo has a couple takes as well on this topic. But how do you think the next 5 to 10 years will look with edge computing, Rahul? Do you think it's going to be ubiquitous? Do you think every space vehicle, spacecraft that's deployed will have some sort of edge computing capability on it?
I don't know if they'll be ubiquitous in that sense, but with the cost of computing going down, whether it's edge compute or just more powerful primary processors, I think we're going to see a lot more processing capability in orbit, and a lot more distributed processing. Ramon.Space is only one of a dozen companies that are doing edge computing. That suggests a huge trend in the market towards having these modules. So I think we'll definitely see these proliferated on orbit.
Yeah. Yeah, Gonzalo, what do you see as the future? Maybe future capabilities past what we are developing now. So like what could the landscape look like in 10 years?
Well, I am with Rahul in here that I think that the cost will go down of these systems and they will continue to proliferate. But as you were mentioning, lately it has caught my attention that looking even more further into the future, there are other emerging kind of technologies coming down the road. One of them being neuromorphic computing, which is an alternative to the idea that I was discussing at the moment, like not having a very general platform where you can deploy very easily. In this case, you have a very specific platform, which is neuromorphic computing, which it's able to operate with very low power and very high throughput. And it comes with several advantages. So like high energy efficiency and much in theoretical radiation resistance, given the characteristics of how it operates. So this is something that I'm looking forward to see the development in the coming years. Right now it's in its infancy, but I think neuromorphic computers and neuromorphic cameras as event-based cameras are something to have an eye out for out there.
Yeah. Cool. And then there's a question in the chat on comparing or finding commonalities between edge computing tech and use cases in space industry versus other industries. It's a kind of a open-ended question, but do you see, Jennifer, I could toss this one to you. Do you see any commonalities or through lines for edge computing?
Yeah, I do. I mean, I think mass storage is a major commonality that we're seeing among all of them. And mass storage that is resilient for longer periods of life than current COTS available terrestrial storage SSDs. I also think that the realization of the applications we're just scratching the surface on. Development of algorithms and the software technology, as my peers have said, continues to evolve. So I do believe that we'll become more efficient over time and address some of the pain points that our customers see in terms of power availability for edge computing. But I really see that it's at the application layer for AI on edge computing that's going to really has the ability to define the future of space, really.
So there's another question on CubeSats, Jennifer, that what are the options for edge computing on smaller satellite platforms such as CubeSats? And this might be a good follow up, given there's limited power. You'd have limited power with CubeSats. Is that something that you offer now or are thinking about offering in the future as the product gets more and more efficient? Just as we talked about, the computing in general has become more efficient.
So, from my perspective, and what I've seen in the industry is kind of the reverse, where those companies that are highly specialized in the area of CubeSats are now looking to make their platforms a little bit larger to support more computing in space versus us making our platforms smaller. That's not really something we look at in terms of the size and the weight. Power efficiency is the exception there. But we're not a fit personally for everybody. But I have heard from some of those very prominent players in the CubeSat arena that they are looking to increase the size of their own spacecraft.
Good point. And I want to take a brief break to ask all three of you how people in the audience can reach you if they have questions after this. Are you guys all on LinkedIn? Is LinkedIn a good place, or email?
LinkedIn, our website, whatever the case. Yep.
Yeah,
Email.
perfect.
Yeah, all of those work.
Okay. Yeah, I find LinkedIn now to be perhaps the easiest rather than
Yeah.
giving everyone's email out. Just shoot people a note on LinkedIn. Cool. And then we have another question in the chat. Let me find it. Actually, you know what? I have a question for Gonzalo that I want to talk about, and it's something that you mentioned very early on in the webinar on collaboration of data.
Mhm.
And that I think what you're referring to is in orbit sharing of data to maybe for I don't know, surveillance purposes or RPO purposes, or just to have more data for these computers to be able to process. How do you look at that, and what do you think the future of that is?
Yeah, definitely. Data is the life and blood of AI algorithms. That's why they are called data-driven systems. And the problem with data for space applications, any model like pulse estimation, computer vision, control in space, it is that it is very scarce. We don't have that many examples of data. And I understand that space is a very sensitive environment when it comes to sharing data and sharing insights but there are, and actually there's a question in the chat there pointing to that about federated learning. So there are these kind of technologies called PETs, privacy enhancing technologies, that can be used to share the data or the insights or train models collaboratively, distributely through many platforms. And I think that could be a future, that something that we should explore together in the industry, the capability of collectively gathering more data to have more robust algorithms and make in this. It's also very a risk adverse industry. So like there is concerns about how AI can be validated, and for that we need the data. So like there is a benefit for everybody if we can do this together, and there are technologies to do it. So I think that's something that I could see a very powerful driver also for edge computing. The ability to do this federated, decentralized training of models, or collaboratively training models and sharing those models without needing to share the sensitive data that everybody is gathering.
Great. I think that is a good answer to end on. And I want to thank the audience for coming, and obviously three panelists. It's been really, really fun. I know we didn't get to all the questions, so I'll speak on everyone's behalf. Just reach out via LinkedIn or these company websites to follow up. And thank you all for joining. This has been a really interesting and fun conversation.
Yeah, absolutely.
Thank you very much.
Thanks, Jack.
Thank you.
Absolutely. Thank you much for the invitation.
Thank you. Take care, everyone.
Bye-bye.
Bye.
Good day, good night.
Yeah.